Bismillahirrahmanirrahim. Assalamu alaikum and welcome to Industrial Electronics course. This is our first video. So, introduction and motivation of the course will be discussed. The course objectives, what will be the course learning outcomes, and introduction to industrial safety principles will also be discussed in this video. So, let's start our discussion. What will be the course objectives? The course is divided into four main parts. Our main topic is to understand the automation of the process. So for automation, we need measurement of different non-electrical quantities like pressure, temperature, speed, flow, etc. So these measurement, the output of these sensors will be fed to the PLC or relays for controlling of machines. So for whole this process, we need to measurement of non-electrical quantities. PLC will give the command to the motors or machines to switch on or off the motor. But how to control the speed of machines will also be discussed. In short, all the devices, circuits, and systems primarily used in automated manufacturing or process control will be discussed. There are three course learning outcomes. The first is that we should be we should be able to recognize and explain the operation and specification of wide variety of sensors and electronic components. So if in any industry or in any process, the electrical components are shown, you should recognize the physically or in or their diagram, you can recognize the component, the purpose of this the component, interpret ladder diagrams. Ladder diagrams are used for representation of automated process. The details of ladder diagram will be will be studied, and how to understand, interpret ladder diagram, and how to make this, how relays and digital logic circuits successfully control variety of industrial applications will also be discussed. AC and DC motors are important part of industries, how they operate and how to control their speed and torque characteristics will also be discussed. And finally, our third course learning outcome is to analyze the architecture of PLC, writing PLC programs that are written in ladder logic will be studied, and process control using PLC will be discussed. So safety is the number one priority in any job. Every year, many incidents occur due to lack of every year, many electrical incidents cause serious injury or death. Many of these casualties are due to the young people entering into the service or workplace. They are involved in accidents that result from carelessness or from the pressure and distractions of a new job. As you are a young engineer, you will be entering into service, so you should know the safety principles and the importance of safety for yourself and also for the equipment that you will be using. The main safety should be against the electric shock. The human body, because the human body conducts electricity, even low currents can cause severe health effects like spasm, burns, muscle paralysis, or even death can result. depending on the amount of current flowing through the body, the route it takes, and the duration of exposure. These are three factors that affect the outcome or loss of electric shock. The amount of current is the first one, the route it takes, and third one is the duration of exposure. So if we can minimize any three of these, we can reduce the effect of electric shock. Body resistance can be divided into external and internal resistance. External resistance includes the skin resistance, whereas the internal resistance consists of body tissues and bloodstream resistance. Skin resistance differ if the skin is wet or dry. If the skin is dry, the resistance will be higher as compared to the wet skin. Dry skin resistance is 100K to 600K, whereas wet skin resistance is only 1 kilo ohm. So the loss with wet skin will be higher. So if anyone is using the electric equipment, the for example, if we manually controlling the any electric equipment, we should use dry hands or the skin must be dry while using any electric equipment manually or turning on the switch. Internal body resistance because of the fluid is very less, and ear to ear very sensitive region has only 100 ohm resistance. So what will be the current passed if 220 volt with wet and dry skin passes through the body? So with wet skin, simply using the Ohm law, you can see that it is 0.22 milliampere, and for dry skin, let's suppose we have 100K resistance. This will be 220 divided by 100K, that is equal to 2.2 milliampere. So here we have 220 milliampere. So the current with wet skin is very large as compared to current with dry skin. That means the voltage is not an accurate or reliable indication of shock intensity because the body resistance changes widely. So it is impossible, or we can say that it is difficult to state that how much current will pass from a given voltage. So the amount of current that passes through the body is the main factor that that describe the effect of that will be main factor that shows the amount of loss, and the length of time of exposure are perhaps the two most reliable criteria of shock intensity: amount of current and time of exposure. The pathway through the body is another factor influencing the effect of an electric shock. For example, the current from hand to hand that passes through heart is severe, and hand to foot. So, if any current that passes through heart will be more dangerous as compared to the if current is only from in only one arm. And head to foot passing through heart is also very dangerous. There are few current values that are shown and their intensity, current intensity and their effect is shown here, starting from 1 milliamp to 1 ampere. So we can see that 900 milliampere can light a bulb. So the red area passing through her is very dangerous. So any current above 95 milliampere will be considered as dangerous current. The most common electric shock related injuries are electric burns, thermal contact burns, and arc burns. Finally, what should we do to protect or ourselves in the industrial environment? Personal protective equipment (PPE) should be used in all industrial or work environments, starting from hard hat. In fact, the hat, for example, if any person get a heavy material on his head, it strikes on the head, the head will not completely remove the effect, but it will slow down or reduce the effect. That is, reduce the effect of contact. It cannot remove the effect, but for example, goggles protect the eyes. The goggles should be made of complete plastic instead of using any metal. Tight cloths consisting of cotton material instead of polyester should be used. Safety shoes protect our foot, and no rings or metal watches, etc. should be used. So this is our today's discussion on the safety principles. Thank you.